Welcome to Data Science 1, Probability, Binomial Experiments Part 1. Okay, some things we need to remember in order to be able to pull this off. So, we have to remember about the multiplication rule. We need to know what combinations are. We need to remember that random variables are how we measure the outcomes and turn them into numbers. And we have this idea of a probability distribution, which is how are the probability assigned to the values of the random variables. If you aren't familiar with these concepts, go back and look in the previous videos and we cover all of these items. All right, in the last video we talked about the Bernoulli experiment. It's one where you have exactly two outcomes in the sample space. So we've already seen goal, no goal, a few more, on, off, alive, dead, pregnant, not pregnant, success, failure. Now, there are only two possible outcomes and there are no in between on any of these states. Okay, so a binomial experiment is where there are n independent trials of a Bernoulli experiment. Here, independent means what we talked about in the previous video about independent events. It means that the outcome of one Bernoulli experiment has no influence on any of the other ones. Okay, so and specifically no influence on the probabilities of the other ones. Replicating experiments are always a good idea, and this is just taking a Bernoulli experiment and replicating it n times. So let's look at this. Suppose our experiment is goal, no goal, okay? And we want to replicate 3 goal attempts in a way that one doesn't influence the other. So when our sample space for this is goal, 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 no goal, and if you go all the way through these, you can see I missed all of them here. Okay, this one I hit all of them, here I miss all of them. So there are 2 to the 3 possible outcomes due to counting, right? Because this one has 2 options, this one has 2 options, this one has 2 options. Now that we have the sample space, we need a random variable that's going to turn these into numbers that are meaningful, okay? In this case, we have a specific setup that we're going to do. So our random variable is going to be the total number of goals. Okay, so we're adding up the Bernoulli outcomes of zeros and ones. So here xnnn is 0 since I missed all of them, xnnng and xngn and xgnn equals 1 since 1 goal was observed. And so on, 2 goals observed, 3 goals were observed. And that's all we have. We can't observe 4 goals because we're only attempting 3. Okay, so now we need get the probability distribution for this. So if we use the equally likely outcomes approach, this is where independence comes in and really makes the impact here. We can simply count up the number of outcomes that match the random variable and divide by the total number of outcomes, which are 8. Okay, so f of 0 is the probability that I miss all of them is 1 over 8, since there is one outcome that has no goals. Okay, f of 1 is going to be 3/8 since there are 3 of the 8 outcomes that have only one goal. F of 2 is going to be 3/8 since there are 3 of the 8 outcomes that have exactly 2 goals. And here f of 3 is going to be 1/8 since there's only one outcome that has all the goals. So here you should put in technically f of x equals 0 otherwise to account for the fact that any other value of x would have probability of 0 because there's no outcomes that would actually match it. But we're going to be loosey-goosey with it for a little bit, and as we move along, we'll become more and more formal with it. All right, so if we clean this up, here's what we end up with. F of x equals the probability x equals x. So we have 1/8 if x equals 0, 3/8 if x equals 1, 3/8 if x equals 2, 1/8 if x equals 3, and 0 otherwise. Now, we're going to play with this more in the next video because there's an easier way to do this. This is kind of the brute force way. You got to list everything out, count everything, and we'd like to use our counting rules to help us do this in a much more straightforward manner. All right, so binomial experiment is associated random variable and probability distribution are really, really important. These types of experiments are all over the place, okay? It allows for basically the replication of a Bernoulli experiment, which is the simplest experiment. And replication is always good. You always want to have more information about something than less information. So seeing if it succeeded more than just one time really helps out. So the sample space can be really quite large. If there are n trials, then the number of outcomes is 2 to the n, which can grow very, very, very quickly. The random variable is simply the number of successes the outcome has. So if I tried it 7 times and I succeeded 4 times, there you go. The answer is 4, is what the random variable is. The probability distribution is a little more complex, and it requires us to examine each outcome. And I put here for now because in the next video we're going to figure out an easier way to do this. So let's go figure out the easier way to do it in the next video. See you there.